It was very interesting, and it was very helpful in like learning how some of these sort of things are done. I don't know if it was really like engineering, but it was fun.
Kind of a close up into many of those abstract things that you learn, and they are abstract until you kind of like zoom in and be able to be doing them. So is any of you interested in doing research or has ever thought about it? I'd like to see any of you. I mean, research can mean from research in education to scientific research, and there's a broad range there. It could be science education research, and then all the scientific fields. So today what I'd like to talk a little bit about is about the program that CBSD is hosting in the summer for undergrad students. We've been doing this for 6 years. This will be the 7th year, the 7th cycle of internship. And last year we hosted 30 students. It was the largest ever internship. And I think that's going to be it, because it's probably too large to handle. So we are having a summer internship. The idea of the summer internship is that you get involved in real research projects that are going on on campus, and here or at the Med Center. The areas of research it's all under biophotonics, so there's something related to biophotonics, but not necessarily they are just doing biophotonics. It could be going from molecular biology to plant biology, to engineering, to computer science. It could go all that range, so you have to figure out what you want and what kind of thing you want to be involved with. The program starts in June, and it can go for 8 to 12 weeks. It really depends how the experience is going for you. If it's really working for you, after the 8 weeks, you can extend for 4 more. And in that period of time, you are involved in real research in the lab, and also you are participating of seminars that happen weekly, and a lot of other activities that are part of the internship. The cycle for applications for this year has closed last week, but this is an introduction for you, and it's something that hopefully in some point of your undergraduate career you are going to be looking for in any of the fields that you are interested in. It doesn't have to be with CBSD, but I highly recommend that in some point you participate in something that is hands-on, to either realize that that's your passion or to realize that that's not, but to really figure out if you are cut off for that kind of science-related thing that you choose to do. Do you have any questions about our program? I just put the web page, with all the information. You can go there and look at all the requirements around what you need to apply for, what entitles. Basically, our summer internship and most of summer internships are paid, so you get paid to participate in this. Our summer internship is $500 a week, and I can see more faces interested all the time. I mean, yeah, things changed. So it's $500 a week, and you decide your housing. So wherever you're living right now, it's fine. And you can choose from laboratories at UC Davis, the Med Center, Lawrence Livermore National Lab, or I think basically that's it. That's what we offer. So I'd like to introduce 2 of the previous summer interns. So if you, they were both participants of this same course that you are taking right now. So this is Sabrina, this is Adrian, and they were both summer interns in the past cycle, and they were doing different research, very different things. So I invited them to tell you their experience there and what came out of it and what it meant for you and what other things are you up to.
Okay, so I was at the Med Center in Dr. Kit Lamb's lab. It's a cancer research lab. What I was doing is Should I really explain all this? Okay. So he makes random libraries of peptides or small molecules and screens them to see if they bind to cancer cells for cancer therapeutics. And so what I was doing was trying to find a way to glue the beads to a slide so that we could scan through them really quickly and reuse the slides and reuse the same beads and not have to keep remaking the beads that have those compounds on them. So it basically make the process go faster. So that's what I was doing in the lab.
What was the general purpose of this research? The general goal?
To find diagnostic and therapeutics for cancer. All different kinds of cancer. It was a really big lab, and there was tons of people working on tons of different things. So that was my little part. I didn't actually achieve a end product per se, but I got a lot of information on different methods and different ways to do things, and a lot of testing done, I guess. So that was helpful. As far as in the lab, I had a really great experience. There was a lot of undergrads in the lab since it was such a big lab. I was able to ask them questions, ask grad students questions, ask any people in the lab. It was really great. It was a good learning environment and everything. What else should I say?
The rest of the internship.
Oh, okay. Rest of the internship, the seminars that we had here and the events with the other interns and stuff were really cool. I learned so much in the different workshops that we had here. We had a career panel come that was really cool, and we had just a diversity workshop. I don't know. That one was cool. And then also we did a couple things we went bowling and we went out to eat and stuff, and it was great to get to know the other interns, and we started hanging out outside of the scheduled events or whatever. So it was cool. I met a lot of cool people, and yeah.
All right. My name is Adrian. Just wondering, is anyone at BME here? Biomedical engineering? Anyone? Okay, never mind. Anyhow, yeah, I am a biomedical engineer. I am a junior right now. I participated in it just last year. I was placed in the health sciences district where GBSF is, which if none of you are BME, you'll probably never go there. It's kind of located off campus slightly. But I was placed in Laura Marcoux's lab. She focuses on using lasers to diagnose particular diseases such as atherosclerosis. By laser, it's not pierced through metal. It's very weak. But essentially, the lasers that we're using they're in the UVA, UVB range, and they can also be used to diagnose cancer. So we know that while the sun's UV rays, they can cause cancer as well. So while diagnosing cancer, you don't want to be causing cancer at the same time. So essentially, my study was to determine the phototoxicity effects. So in the process of diagnosing that cancer, are you causing cancer at the same time? Is this harmful? At what levels of energy will this be harmful? So essentially, that's kind of what I was going into. First few weeks, to be honest, of the internship, of getting into any lab, you won't really be doing much. I spent my time reading papers, and you learn to read a lot of papers in the research field. And I guess overall, the internship was I felt it was a really good experience. The classes, the other supplemental things that CBST provides, there's a first week intensive training. It kind of prepares you for what to expect during lab. I like the little activities that you do. So one of them was, can I show that? Okay, cool. Basically everybody gets blindfolded, and you're all you all hang on to a piece of rope that's in the shape of a circle. And then Anna will tell us, well, make a square, make a hexagon, make something. And then just by communication, you need to figure out how are we going to do this. So I think
30 people.
Yeah, 30 people. So it was surprising. It works surprisingly well for most of them. And I feel it's a very good activity to kind of hone critical thinking, kind of the ability to think on your feet. It's, in any sort of research, you're going to need to do that. Whether it's, well, can I use a pipette for something else? I think someone else used or there was a demonstration that used a pipette to like hold two optical fibers together because I forget what happened, but it worked really well and it was really simple. So it's necessary. So you'll think on your feet. The internship, you do meet a lot of great people. You do. I feel there's a very diverse group of people that there are to meet, and there are many different ways of thinking. Is what I learned from that, and being able to see things from different perspectives is always nice. I think one of the other things from an academic perspective or I guess futuristic perspective that I enjoyed most was a panel where there was a med student, people who had MDs, PhDs, people from academia, and people from government. So you get a pretty wide, industry. So you get a pretty wide perspective of what is out there in the jobs, what is each of them like. I liked one of them where they said usually a regular workday is 9 to 5. They said, well, I work 9 to 6, but I get every other Friday off. So I think that's kind of cool. I'd do it. So, yeah.
There's also a retreat, an annual retreat, where it's a big conference where all the people related that is doing science, so that are doing science related to hackathons, go to this big place. We normally do it in Lake Tahoe at a resort, and all summer interns participating are going to that one. So in that point, you are exposed to the research that is going on in the center, and you're able to network and interact with all kinds of people from other undergrad students to postdocs and professors in a one-on-one situation. And in terms of your, what are you up to now? Did you apply for a new internship? What are you into these days? In terms of your career development, did you like what you're doing and what you were doing and you would like to continue research, or it meant that for you this is not it and you're going to go somewhere?
So for me, personally, before this internship, before this summer, I was like really into research, and that's what I was going to do with my life. I was like set on it, basically. And so I went into it feeling like that, and when I came out, I was kind of like, well, I don't know. That's kind of really specific, and I feel almost like there isn't enough motivation for me, I guess. It's like so specific, but I still feel that research is really important, so I'm going to try out some other labs and continue doing research through my years. I'm looking for a lab right now, especially to do I don't know if you've heard of the thesis, undergrad thesis. Okay, cool. But it also made me realize that I might want to look into medicine, which I hadn't been thinking of before, because I think mostly because it seemed like so many people were pre-med. I didn't want to be following the flock. I don't know. But if it's something I'm actually going to be interested in, it's worth looking at. So that's what I'm looking at right now. I'm doing a clinical internship at the hospital this quarter, or spring quarter. And then I'm going to Thailand and working in a couple hospitals and with a couple doctors there. So, yeah.
For me, I am currently still in Dr. Marcu's lab because it's on campus and I can still go. I'm actually working on a slightly different project now. It deals more with cells, and I guess, should I go into it, or?
And you're still enjoying that?
Huh? Yeah, I do. I feel that your environment has a very heavy effect, or it places a very big effect on how you treat what you do. I actually worked in the LAM lab my freshman year, summer of freshman year. It's a giant lab. People were very friendly, but I felt a little stupid there because everyone, I swear, everyone's a genius there. It's crazy. I recognized, looking back, I was the grad student I was working under, she was a genius. There was nothing else to it. I like Dr. Marcu's lab because I feel everyone's really down to earth, everyone's really, really friendly, and honestly, I just really love working there. Dr. Marcu's a great person. She always stops by lab, and because some PIs will just sit in their office, and it's not very nice. But Dr. Marcu will come around. It's like, oh, how are you doing? Do you need help on anything? So it's really nice. In terms of future, I'm still exploring. I guess just because, as Sabrina mentioned, your research is very specific. I don't know. I sort of enjoy what I'm doing. I don't know if I would like to do it for the rest of my life. So for now, I'm pretty much just exploring different perspectives. I've considered teaching, kind of just going into the field of education. I enjoy teaching science, and I'm a tutor at chemistry. If you ever need help in chemistry, I'm in the Seguno Academic Advising Center Monday through Wednesday, 6 to 8:30. So if you ever stop by, you can say hi. But yeah.
Hey, Adrian, I really thank you for mentioning the thing that you've been in 2 different labs and the 2 experiences took you to very different conclusions in terms of how you felt about the experience. And I think that's really important to really explore, because one little experience can really turn you off about a complete field that many years later you can come back and say, oh, it was not the science or the type of work, it was that particular environment that I felt it turning off. So that's something.
That's why I want to get into another lab.
To kind of explore, move around, and figure out your options. There are a lot of options around, so please use them. Any other comment you want to have, or any questions to them?
How many of you think that in either as a sophomore or junior you would like to have a research experience? So most of you, or the majority of you. How many of you are pre-med? Remember. Very few. Okay. So we will convert more of you into pre-med. No, just kidding. Just joking. That's not what we're trying to do. The important thing here to think about is that having a research experience not only helps you figure out what you might like in research, but it might help you figure out that that's not the kind of thing you want to do. Both of those are very important. Because you really don't want to be in school for 8, 10, 12 years by the time you're out of graduate school and postdoc, and something that you don't want to do. And that goes the same for medical school. I would suggest, if those of you that are interested in medical school, also volunteer at hospitals, try to get a better sense of what that job is really like. Okay. I can tell you that my own personal experience, I came in when I was your age, I thought I was going to be an MD. I was pre-med. Then I started getting interested in international law and international kind of things, and I wanted to become an international translator, a multilingual translator. Then I thought, okay, I'll become a dentist. I went and volunteered at a dental office in Italy for a summer, and even did things like tooth extractions. I mean, things that you'd never be allowed to do here. And I didn't know, hopefully you're not allowed to do those things there anymore either. But I saw that that was not the gig for me. And then I ended up going into research, and I did engineering research. I did straight biological research, and then I did biophysical research. And where I could blend like programming and wet things and dry things and moving things, and that I like. So I ended up getting a biology and a chemistry degree, dual degree. It took me 4.5 years instead of 4, but that's what I ended up doing. The good news is, for all those research points, I got paid, except for the very first ones. Sometimes you have to volunteer at the beginning to get yourself your foot in the door. But I guess what I'm trying to say is that you can have variations in your thinking and explore them, and that's what these 4 years are really all about for you guys. But I guess the main message I have for you is get those experiences. Because if you just go through your courses and you think, oh, I really like this class and I really like this other class, and it's leading you towards a certain path, and you never try out putting your feet in that path for real, like whether it's research or whether it's medical related or whether it's dental, whatever it might be, you don't really have a true sense that's what you like. It's easy to get lured by the images we get on television, or our parental influences, or brothers and sisters that might be pushing you a certain way. It's a lot different for you to actually be in there and try it. So I highly, highly encourage you, if you have any interest in research, which we saw the majority of this room has some interest, that you get an experience, or more than one experience. Okay? So you can really, truly find out what you like.
Just a note on the internship. It's a really good place to start for research because it is paid, and a lot of places aren't going to pay you for one to start out with. 2, they want you to already have some experience in the lab. So if you apply to an internship, you're more likely to get in without experience than just approaching a professor, because they don't know anything about you versus the internship is a bigger program. They're not as invested in you, I guess.
Yeah, it's a safe place for both sides.
Yeah.
For the student, because the student is exploring, and your commitment is for 8 weeks to 12 weeks. If you don't like it, you don't have to put any excuse. You just go. And for the professor, it's the same. It's like, I'm going to see what happens with this student and what the relationship with the student and the whole dynamics and how the student's lives what I'm doing. And if this doesn't work, goodbye at the end of the 8 to 12 weeks. And if the thing works, it's like, okay, are you still coming? Are you interested in coming for a second summer? You have other doors that are open, including getting letters of rec for whatever other internship or position you want to get. I mean, it really opens up broad variety of things that is worth trying.
So just so you guys have clear, your paths are, you either cold call a professor or email or whatever it is, or show up at their office or their office hours, whatever, and you say, I'd really like to do some work with you. If you do that, be prepared. Know something about their research ahead of time. Have read some kind of paper from their lab or talked to some of the students in their lab, something. Don't go in there totally cold and just say, I really think research is great, and I really like to do some research. They're going to think, okay, why? Why do you want to do this research? What are you interested in? What made you pick me? You know, why do you want to do this? They're going to really question you. Especially if you go in saying that you're pre-med, they tend to not find that as attractive. Okay, just be aware of that. Unless you're going to the medical, to do an internship with a medical group or a medical doctor that has also a research practice, then that's a different story. That's one way, and you can do that for the easiest way to get in is if you do that for free. Okay, if you do that as a volunteer, and a lot of times your first experience will be that way as a volunteer. You can also do it for credit, or you can join a program like our program, or all of the STCs, for example, all the Science and Technology Centers, of which there are 17 right now, have one of these programs. Sometimes it's called a REU, Research Experience for Undergraduates, but you can find all these online. They're all competitive. Ours, for example, for those, this year it'll be for about 24 slots that we have over 150 applicants. Okay, just to give you a sense of that.
There's no advertisement of the internship. I mean, we talk about it in this class and in 2 more classes.
That's it. So be aware that and we have people from all over the country that come, and it is highly competitive. So you're not guaranteed, for example, if you have no research experience, you're not guaranteed to get one of those just because you've been in this class. It doesn't quite work that way. It's a competitive process. Though, with that said, either in one of those scenarios, either a volunteer scenario, a credit scenario, or an actual internship scenario like with us, every year out of this class, we've had anywhere between 2 and 4 students participate in one of those ways. Okay? Usually 1 or 2 come into the internship, the paid internship, and usually 1 or 2, sometimes 3, do the other routes, the credit routes or the volunteer route. Okay? Usually what happens is right now you're thinking, oh no, I don't even want to think about this. And then a year from now you email me and say, oh, I'm really interested about, I just had that happen about 2 months ago. 4 prior students were like, oh yeah, I'm really interested now, I've realized I need to do this. And so try to send me the email not when you're a junior, but ideally when you're a sophomore and finish, going to be a junior. That's your better time to do this. Either starting this coming summer or the next summer, okay? Don't try to wait another extra year. It makes it even harder. Okay. Thank you.
Do you have any questions while we are still here?
They're thinking about their kids. Thank you, guys. Anything else you want to say to them about the IST experience overall?
Was anybody at the Sardines event that engineering held? Yeah. I remember people got frustrated because people were hiding on the roof of the social science building. Because I don't know, I remember there was a huge group of freshmen and then people left because it was hard to find us. Yeah, they were on the roof. Oh, this was in Fall Quarter. Yeah, just to update you all what happened because I felt kind of bad. Because we found them and all of a sudden everybody was gone.
Now you have your quiz back. And this quiz had an average of 8.18 And there was the highest standard deviation we've had on any of the quizzes. So it was about 1.6 standard deviation. So it was clear to me that this quiz, for several of you, you will want to throw this out. We will, based on the suggestion of one of your classmates and some thinking that I was doing late last night, we will throw out your lowest quiz. What I'll do is I'll basically, I have to have 40 points in total. So what I'll take is your top 3 and multiply them so they, times 4 over 3. No, I won't have time. Sorry. I won't do that. Okay? As you saw also, the quiz you got today should at least get 5 points. Right? Because 2 of those questions, it would be hard. I mean, if you answered them at all with anything intelligible, you should be getting at least 5 points. Okay? Well, I'm sure every year I've found very interesting things about you guys.
Well, there was some cheating going on. People were, sharing answers and things like that.
That is always a problem. If I start seeing that all of you want to do the same thing or your talks are identical, then I may dock some points. Okay. So, on this prior quiz that I just handed back, there are a couple of really major misconceptions. Okay? So I want to make sure we go over them clearly and that you guys feel comfortable with what these things are. I know that some of these elements were not blasted at you over and over and over again, but you did get these concepts most of them at least twice. Okay, so I want to make sure that you get what some of these things are. So, the optical window. There was some confusion. Some of you thought that the optical window was an area showing what you're going to image, or where your microscope can image, or how low in a tissue. You were starting to get closer, how low in a tissue you can actually image. And then people were starting to add the idea that the energy might matter, and that certain wavelengths will go through or not go through. So there was this progression that I saw in your answers. And the basic idea is, if I'm going to image something and something living, there's a range of wavelengths where all the other garbage is not in the way of me getting some light through. Okay? And what I mean by that is, if you look, this is the signal of water. The water signal is very, very strong below about 250 nanometers. So I'm going to have a hard time imaging something inside, for example, your finger, if the water signal is the strongest thing there. It's going to be virtually impossible for me to see something besides the water signal. Okay? The same starts happening over here, and you start going in the near infrared. There's these peaks where it's really hard to image something else because the signal from those other species is going to be so low. So in general, the optical window is this range in here, somewhere between 300 nanometers all the way to around 1,000 is your best bet. That's when I can image things like hemoglobin or melanin or other species, types of proteins, things that are inside your tissues. Because I don't have water blocking me. Okay? That's the biggest single contributor that narrows that optical window. So effectively what we look at in the optical window is this part where water has very low absorbance. That's effectively the simplest answer you can give. Okay? It's a part of the spectrum where you can look for given species and water has the least interference. It's your signal. Okay? But you can express it in a variety of different ways. It's the optimal wavelengths at which you can image things inside living tissues. And in general, it's just 300 to 1,000 nanometers. There are questions about that? Like imagine if I was trying to do that pulse oximeter and I was using a wavelength of 200 nanometers over here. My finger, where our bodies, is 70% water. So I'd have a heck of a time getting any signal. And usually when I'm looking for some kind of biological element inside of living tissue, the concentrations of those are really, really low. Right? So I get a nice signal from blood. Blood is one of the strongest signals we have. And look, I can get this really nice spectrum that I can monitor right inside the optical window. So blood is awesome for imaging inside tissue. Okay? Depending on the type of tissue, melanin might be in the way. So, depending on what I'm imaging, if I'm imaging an organ, I don't have to worry about melanin. If I'm imaging skin or something related to skin, I may have to worry about melanin. If I'm imaging somebody with very dark skin, that may have an impact on what I can actually image and where I can get the optimal signal. Again, the idea is getting the optimal signal and not having water interfere. That's the simplest. At that level, that would already be plenty for you to know. Okay? Between 300 and 1,000 is roughly the range. Questions about that? Yes?
Does melanin interfere with the pulse oximeter?
The beauty of it is that the signal, this is a relative graph. This is actually, if you were to really plot this out, this water signal would be even taller. Effectively, the melanin interferes, but it's a constant. And the signal from hemoglobin is so strong, it's one of the strongest signals we have, that it's okay. If hemoglobin had a signal down to here, then I'd be hard-pressed to have it work so easily. But it's an equivalent signal in terms of absorption to the melanin. So I can keep that as a constant, it's okay. It's like I'm only losing half my signal processing power. But if I had a signal with most things that we're looking at are down here, very low kind of absorption curves, then I'm going to have a much harder time. And, the amount of this is an absorption curve, but it also depends on how much I have of it around. If I have a lot of the thing that I'm studying around, then I'm going to get a lot of signal. And effectively, in my finger, I have a lot of blood, and the melanin is only at the surface, the two surfaces. So I may actually, overall, have much more signal from the blood than I have from the melanin. This is just telling you, melanin has this kind of absorption curve, and this is kind of where it absorbs, with this kind of intensity. This does not tell you concentration. So that's the other thing about this water signal. Effectively, the water signal ends up being much higher because it's the majority ingredient. Okay, so it blocks you. So the holy grail has been figuring out sugar concentration without having to prick somebody's finger, right? So diabetics could very easily, they could put a pulse oximeter type thing on your finger, and it would say, okay, this is how much sugar you got in your finger. The problem is that where the sugars absorb most readily, the sugars are ring structures, where they absorb most readily is in this UV region. And not only do we have poor penetration of UV inside the tissue, we also have huge water absorbance. So it blocks you from easily measuring sugar concentrations. So it's things like that when you're actually trying to figure out a new system or a new tool, you've got to take into account what's the concentration of the thing that I'm looking for? What are the other things around it? How dominant are they? Is water going to be a problem? So you're looking for the right part of the spectrum to use. And sometimes it just doesn't work that way. So then you look for another place to measure it. The easiest is take a drop of blood. Then all those other things are gone. But if you take a drop of blood, then we've already got that technology. So biophotonics doesn't help us there. Any other questions? This is just a very important basic concept that is valuable for you guys to know, that it helps you figure out what you can study and what region of the spectrum you can use. And then it also tells you about penetration depth and how far you can study something inside the tissue. So, spectroscopy versus imaging. The simplest answer to that is spectroscopy is a point of information. Right? You guys measured the light reflecting off your finger, the light going through the leaf, the light going through your finger. It was a point type source. And it's usually showing you how different wavelengths of light, energies, interact. Okay? Some interact more and get absorbed, some less. Okay? That's what spectroscopy is telling you. Spectroscopy results in a graph of some kind, or a point value. Like with a pulse oximeter, it's actually measuring the absorbance in two areas, and giving you a ratio. It results in 2 points, which we can convert into a value of oxygen. Imaging is really getting an image. You get 2 or 3 dimensions of information. And you can utilize tags like fluorescent probes to help you clarify that image or to help you focus that image into what you want to study. But it's an image. Imaging is getting you some kind of 2 or 3 dimensional image. Okay? Spectroscopy is looking at photons interact with matter in a wavelength-dependent fashion. Does that make sense? When you guys were measuring the leaf stuff, the transmission and the reflectance, you didn't get an image of the leaf. You just knew how that leaf, that portion of that leaf interacted with photons of different energies. That's the information you got, and that's spectroscopy. Okay? Now, just so you know, there's something also called hyperspectral imaging, which is where you get an image, but you also have spectral information for every point in that image. So imagine getting an image and then getting a full spectrum over a range, 200 nanometers to 1,000 nanometers spectrum for each point in that image. That's hyperspectral. You've gotten an image and you've added a spectrum on top of every point. You might think, well, that sounds really esoteric. This is how all of our satellite imaging works for figuring out rain clouds, figuring out water content in the soil, figuring out foliage coverage. All those kinds of things do hyperspectral imaging. It's just a question of whether you get a full spectrum or you get 5 or 6 specific wavelengths. The older satellites get 5 or 6 specific wavelengths, and then they do manipulations of those. The newer systems actually get a spectrum for every point in the image. Okay? Does that make sense? So the cool thing about this hyperspectral imaging is that depending on which part of the spectrum, you can use different parts of the spectrum to create a different image. So I can create an image of the light intensities at 400 nanometers. I can create an image of the light intensities at 600 nanometers. I can create a light image of the intensities at 700 nanometers. And those different wavelengths will show me different things happening in that sample. They might show me the health of how much blood is flowing in that organism if I pick a certain wavelength. They might show me NADH activity, or some kind of chemical activity if I pick a different wavelength. And that's what we use, this idea we use for detecting cancers or malignant tumors or different types of things that are going wrong in tissue or things that are going right in tissue by looking at it at different wavelengths. Okay? That's one of the ways in which we figure that out. Questions about this? Okay. In vivo phenomena. So, with bioluminescence, you can look for gene expression products. With fluorescence, you can look for gene expression products. Both of these can be used to monitor things like tumors, infections, bone growth, drug targeting, cells doing interesting things like cell fusion. Okay? These are two different things that we can use. Now, this isn't the only answer, because I think I asked you what things can be used with organisms. You can also use infrared if you wanted to, thermal imaging. Some of you answered thermal imaging. That is another valid thing that you can do in vivo. For example, the horse that's hurt its knee and you don't know, and you want to see where the inflammation is, you can do thermal imaging and see what's going on with that. That's a type of imaging that can be done in vivo. Okay? But these are the ones that in the course we primarily targeted. Bioluminescence gene tagging and fluorescent gene tagging. By the way, the last lecture is online, and I'll try to get these quiz answers online too for you, though I may not be able to get to this until later in the week, until Friday or so. Is there a question about this one? This one didn't seem to present as many problems. The first two presented more problems for people. Much more problems, many more problems for people. And then, lastly, I was impressed by the creativity of some of you with figuring out what TBI stood for. It was very impressive and very plausible. It sounded very good. But what we studied is traumatic brain injury with TBI. Okay, that's what we studied. And the kind of weird thing, and he talked to you about a lot of. He went pretty deep into what was going on and how you can have other assaults other than the traumatic brain injury and seizures, and he talked to you about magnesium concentrations, and he went into greater depth. But the simple thing is, originally he thought that 2 injuries close in time would result in more damage and increased behavioral deficits. But what he found is that the brain does not appear to be acutely vulnerable to multiple injuries. It kind of looks like it's protected. And so what he studied next was, while a mild injury might prime the system to make it more impactful when they have a secondary insult, If you have a stronger injury, it kind of shuts the system down, protects it so that the second injury doesn't seem to add greater effect. So the weird thing is, you'd think that if you had one head injury, one head trauma, and then shortly thereafter you had another head trauma, that would be much worse than if you only had one head trauma to begin with, the first one. But what the surprising thing that he found is that if you have a strong first trauma, there's some kind of protection that happens so that when you have the second one, in a sense, it doesn't add. Okay? You'd kind of think that 2 is worse than 1. But in this case, it's not. If the first injury is mild, then it doesn't seem to have this protection. If the first injury is more severe, then it seems to have this kind of protection. And it could be due to the shutting down of certain channels for passing certain ions. Okay? Does that make sense? Questions? I mean, you guys told me about other stuff too that he talks about, which was great. But I mean, this is just the basics of, the very basic thing. And I didn't write it on here, but pretty much, if you guys had traumatic brain injury, correct, you all knew that this was a very important thing that's happening a lot in your age group and with younger folks as compared to the elderly, and that it's a very relevant thing. And many of you wrote that you should wear your helmet. So yes, you should wear your helmet, definitely. Any kind of sport, horseback riding, skiing, bicycle riding. Basketball might be tough, even though you could get a traumatic brain injury. You might get picked on if you wear a helmet playing basketball. But bike riding, you should just do it. And it is true. I've been looking around at the students on campus, and not very many wear helmets, and not very many of any of the people on campus wear helmets, let alone the students. Okay, so now the quiz today. How'd you guys find it? The first 2 questions, okay? Not the last 2 questions.
Got easier.
They got easier, okay. How many of you thought it was easy, the first 2 questions? Medium. Hard. Okay. So this was clearer to you. You also just had the lecture. Hopefully it would be clear.
I had a joke that they don't going to be coming, and just was disappointed that the lecture didn't get up until this morning. Yeah,
I'm sorry. Last night I was just like... It's been a hectic couple of days, I'll put it that way. Okay, so. Okay, so what I was hoping we would do for the next 20 minutes or so is have the groups that did these presentations actually, this is my wife, I need to check. Why don't I have the group that did this come on up. I just want to have you say a few words about your experience, and in the meantime we'll show some of the pictures of what you did. Okay, let's make this bigger. Let me shrink this a moment so you can see it. Okay, so why don't you tell us what you did?
What we were supposed to do was go out in front of the NU and table and do some presentation stuff. But the thing was that our schedules kind of didn't intersect that well, so the only time that we could get out there was 8 a.m. in the morning. So we aren't really going to get that many people. Our planned gimmick to get people to pay attention was the IR camera, but the thing was that people really weren't moving through, and so after one of our friends stopped by, we headed inside with the IR camera and talked to people inside the co-hub, which was a lot more successful because they were already sitting down, they were already stationary, so if we distracted them for a few minutes, they didn't really mind. And so we would actually talk to them for 3 or 4 minutes, and we would show them images of things with the IR camera, and then take their picture. Have we sent it to them yet? Their pictures?
No.
And we're going to send them their pictures in the IR section.
I don't know if our major problem was that people weren't stopped. That was a problem. Probably another major problem was that we had the IR camera, and then if you remember the setup at CBSE, there was also a monitor next to it, and we think the power sources for that monitor weren't working, so we can't show people as they're walking past. if you're just walking past and a brightly colored picture of you pops up, you're probably going to stop and look. If it's just kind of a camera that, like, and people are waving at you to stop, stop, listen to us, it's a little bit harder to do. So we have to try and rely on some of our other gimmicks, wander around, try and pass out papers. People don't really stop for people that pass out papers. Or, try and get people to stick the pulse oximeter on their finger or take their temperature with the IR thermometers. Neither one of those were wildly successful. So eventually we did end up moving inside and finding stationary targets. No other words really come to mind.
And you can see pictures of what they were doing. They were going through the parts of the MU here.
Yeah. Well, we do. We do.
That's what we did.
Yeah.
Well, people are smiling. That's the good
They
news.
really didn't seem to mind. They seemed pretty interested overall, I would think.
I think that's partially because we tried to pick people that looked like they might actually be receptive. We tried to avoid people that were wearing iPods and didn't want to listen to us, or people that were busy writing something like, you look over and think, I think that's homework. Probably shouldn't go over there and talk to them. So, pick and choose your listeners. Targets.
Victims imply that we victimize them. Our targets even is their time to educate them, so we benefit.
So we've got to get you the picture so that you can email it out to them. So I'll try to see if I can do that during lunch. Otherwise, we'll wait. It'll be early next weekend.
Okay.
Anything else you want to add? So what did you feel what did you get from the experience? Have you ever done something like this before?
I haven't ever in front of the MU from being that specific or really done much flyering. Part of my internship now though is going door to door, and so one of the things is that you really get a feeling for how people react when you try to present them with something that they don't go to. And the general thing is, if they're stationary, if you know where they are, they don't mind you coming there for a few minutes. But if they're on the move, you really can't get them to stop because they have places to go. And so tabling in front of the MU, you aren't going to get much. I have a feeling, I don't know how the tabling at the farmer's market went, but I have a feeling that it might have gone a little better because they're there and they're there for a longer period of time. And so then they wouldn't, passing through in front of the MU, they weren't going to stop that much. But once inside, they were willing to, because they were already sitting down.
Yeah.
In the past, I haven't tabled in front of the MU. I didn't do flyers, but in high school when we did AP chemistry, after the AP test, one of the things we had to do was during lunch one day we all set up tables and thought on some kind of chemistry day. We just did demonstrations with people, and that was not wildly successful. High schoolers, they're not going to stop and watch you unless you're doing something really gimmicky. Explosives are big. People, there are things where you can do chemical reactions that you set something on fire and it doesn't actually burn because you just actually have alcohol on the outside and it's protected by water. So, people are dipping money in this and, burning $1 and it doesn't get burned. But, on the other hand, you're sitting there with some kind of pressure lowering, adding device, pressing the button, and it's not that impressive.
Yeah. So what do you think was the easiest thing to share with people?
The IR camera.
The IR camera was definitely the easiest.
It's the most visually satisfying because people could see it right then and there, and so it wasn't even some of the other stuff was a little more medically related. This was just entertainment, oh wow, I look at all these colors, that's fun.
Yeah, makes sense.
The pulse oximeter takes no time at all, but then you put it on, it says it takes 3 seconds, and they get the numbers, and they're great. What does it mean?
Does it matter? Does it change anything? Do I need to go out and do something? Or the answer is no.
Okay. Well, let's thank these guys. Good job. Okay, the farmers market group, come on up. Tell us about what you guys did.
Oh, I forgot there was a stage up here.
So we presented at the farmer's market. We got there at about 7:30 and stayed till around 10:30, 10:45. Overall, I think the flow is pretty good. We, if you look at the percentage of people, going by versus the percentage of people who actually stayed and listened to us ramble on, it wasn't that great. But we had about 15, 20 people who stayed for, a reasonable amount of time listening to us. Let's see, we had the three biophotonics devices there, the infrared thermometer, the pulse oximeter, and the body fat percent meter. And we also had a series of gummy bears with red and green lasers to demonstrate absorption and transmittance. And also for the last about 45 minutes or so, we had the IR camera, albeit with no monitor, but that was pretty. Yeah, it was still pretty popular for the people who were there at that point.
I got the idea that people were drawn to the two posters because they took up so much room, and I think there's a lot of people that would go by the poster and pause, and then if they thought it was exciting or not, then they would go and ask us. Which I was surprised by. I thought that they would just be like, oh, there's people, I want to go talk to them. But actually, maybe there's people doing random tabling so often at the farmer's market that it's not that big of a deal.
I think the poster was the draw.
Yeah, a lot of people walked by and what's biophobonics or something like that. and then that's just kind of our cue to explain it to them. People were very interested in the BMI. So it's wow, something can test BMI with light.
Did you get to do that on many people?
Yeah, a good amount of people.
People want to do that?
Yeah.
Now, what did you guys? Did you guys have to hustle the business in, or did they just wait for them to come to you?
Oh yeah, a lot of people seem like they're just walking through and looking, because there's a lot of tables, a lot of student organizations and stuff like that. And the people who were mostly interested were people who are already in science. And actually, one person was actually working at CBST. So
I think he said he was visiting the center. I just noticed he had a hat that said photonics. So I better know what I'm talking about.
He pulls out his UV laser.
Interesting. Cool.
It's wow.
Okay. And do you have any comments to make about the use of these tools when it's sunny? Was there any issues with
the temperature thing?
That's enough for the first 2 hours.
Yeah, apparently you're old dying.
Yeah. Thermometers, if they're cold, if outside it's 50 degrees, and they're cold, they're somewhere. The glass is so cold that it doesn't have a reading. So they can't have to be around room temperature or warm. And they probably wouldn't work if it was 105. So that's an interesting thing to realize about those techniques. Now, the infrared camera, can you tell me a little bit about how you guys used it in this setting? Did you have a monitor?
Yeah, we just, we showed people the camera, and we flipped it around, turned it on us. Then, because the thing, you could flip the lens and the screen. You could actually do it so that, you could show the people their image as, if you're looking at it. And, then we just, we showed them the little welder's mask thing, and just demonstrated how that does not, you can't see through that because you
wanted to get his finger in the. We got a picture of him. Oops. We got a picture of him with his dad. It's in the infrared.
Yeah, I noticed that we had a bunch of people come in pairs, so like the partner they were with was able to view the picture.
And you notice it would have been nice to have like an umbrella or something, so they would be like staring into the sun. You know, they're like, what was it? What was you were seeing here? You can see there, for example, you're talking to them and staring into the sun. Okay. Anything you want to say about having that experience of being out in the farmer's market trying to talk about science?
Cold.
Yeah, it would have been nicer in the summer.
Would have been nicer in the summer. Okay.
There seemed to be a lot of people there who actually knew the science behind it. I remember one woman walked up and asked me, so is light a particle or a wave? I think I've heard that one before. But yeah, a lot of people were asking about the mechanics behind the pulse oximeter and the body fat analyzer. So it was encouraging to see that people are actually interested in learning how these things work.
Okay. Thank you, guys. Okay, next group was the middle school group that went yesterday. Yeah, I know.
Yeah, I guess so. Well, yesterday we went to the middle school in Woodland and taught a 7th grade class about photonics. I actually liked it a lot. I really liked being able to interact with younger kids, and so it was really cool for me. We started off by talking about just like the basic definition of light and how light works, and talked about some of the different wavelengths and showing the spectrum. And then from there we went into the IR camera, and we pulled a couple kids up and used the ice cubes. We used the mask, the garbage bag. We had them blow on paper, and for each of the kids that came up, we gave them glow sticks, and we told them not to break the glow sticks. And then after we were all done, we took a picture of the class with the IR camera as well. And then after everyone sat back down, we talked about chemiluminescence and bioluminescence, and that's when we had them crack glow sticks, and so that was really cool. We could show them that, and we talked about that for a little while, and then we moved on to how you can use biophotonics in medical applications. So we talked about the pulse oximeter and the thermal, or the IR thermometer. And they didn't find those as cool as the IR camera, but it was still pretty cool to see them playing with them and using them. And then I think we ended up just talking about the new advances in biophotonics and that sort of thing. But it actually took a lot longer. It took 40 minutes for us to go through all of that stuff. So it was pretty cool.
And how did you encourage interaction with the students?
We asked a lot of questions, pretty much everything that we talked about. I was well, why do you think it's doing this? Or this person's head looks really hot. Why would their head be hotter than the rest of their body? Just pretty much everything that we talked about, we asked them why they thought it was happening, or what they think was going to happen, or when we talked about the animals, why do certain animals light up? Why would it be beneficial for a firefly to light up, or for that fish with the horns thing? Rod, why would it be beneficial for them to light up? Just getting their minds to start understanding. Because it was hard, because they don't even know what an atom is. So I was trying to explain how photons and electrons and everything, and they just straight over their heads. So it was hard, but it was cool to see them start to get engaged. They were asking questions back, so they were trying to understand it. So
right.
That's pretty cool. I really like it.
Have you done this before?
Not just with this, but my mom's an 8th grade teacher, and so I help her out sometimes, and I really like that. Yeah.
Well, thank you. Okay, so tomorrow is the last group going to a different middle school, and it'll be interesting to see. We've never done anything at that middle school before. It's a new middle school. It's actually at a school. It's a charter school associated with the university. The School of Education here has gotten together and created that charter school with some other groups. So that should be interesting to hear about. And we'll hear about that on Monday. And then we'll hopefully see our videos. And the cartoon. How are you guys? How are you guys doing? I know you guys want to borrow the microphone again, so you get some other touch-ups on the audio. How's the cartoon going?
have like different storylines written out. We're just going to draw.
Okay. Sounds great. With that said, the group that needs to go tomorrow, please come and learn to use the camera for a few moments, and we'll get you the microphone as well. And otherwise, I will see you guys on Monday. Monday we're going to be primarily reviewing, going through every single piece, and also we'll go over the quiz. And we'll start the process of submitting evaluations.